Okay, welcome to day 2 of your training for Igen4. Um, Last time we talked about the paper path, we talked about the waste containers in the back of the machine. I forgot to mention the carrier dispense unit, which is important. It's basically just a hopper that fills up with carrier, which is steel powder, which mixes in with the developer housing in each developer housing. And what happens with developer is that it ages pretty quickly, and it affects the print quality. So previous models of the Igen3, they had to do developer changes on their own, but starting in the Igen4, developer changes became service technician responsibility, and they are far less frequent. We were doing them maybe once a week, sometimes more than once a week. It depends what you're printing. If your image quality is critical, then you're gonna need to do what you have to do to get it to print correctly. But Xerox made a huge improvement when they went from the 3 to the 4 with the carrier dispense unit, the CPUC, which I will show you, and your color maintenance. That keeps all the print quality, print color densities consistent. There's still wear and tear in the machine, and operator maintenance is a big part of maintaining that consistency. But the from the 3 to the 4 it's just a significant improvement. That's why it's you don't like it's so significant that I would never recommend you buy the Igen3. Start at the 4. The 5 is not really that much better in my opinion, but the 3 is, the 4 is good. Okay, so I am going to show you the xerographic components and the fuser area, and then that'll be today's lesson, and then we'll move on next time to the software. We'll set up print jobs, we'll set up the trays, paper stock settings, and then we'll start running jobs, and then down the road we'll do actual maintenance procedures one by one. I'll tell you the best way, the right way to do everything, and what the operators are responsible for, what the technicians are responsible for. And there's a lot of things. There's a lot of things to talk about when it comes to maintenance and then operating this machine. And again, that takes weeks, it takes months, it takes years before you actually get good at doing this. But it takes months to learn how to do this and to get comfortable with procedures. And it takes years to be good. And that's if you know what you're doing. That comes from my training program, unlike Xerox training program, where they, I don't even need to say anything. Okay. So we're going to open up the press here. We got lower middle door. We're going to open that. We're going to open the top right print engine. We're going to open the top middle. that just swings open. First thing we gotta do is unlock. There's a locking mechanism down below, and you can reach it with your foot and just kick it to the left. It's hard to see, so you kind of have to get the feel for it. But the first several times you'll probably use your hand and unlock it. You can only unlock it with your foot. You can't. I don't think you can go backward the other way. It doesn't. It's not designed for that. So. That's like the extra lock that allows you to release these two long black arms. And so when you release, you release and it pulls out into the right toward you and to the right toward you. The machine will power off when you do that. So now you're entering service of the print engine. So you're going to start working on it. The only time you're opening it up, it won't run when it's open, but you're opening up so you can get access to the machine. Okay, so now we're looking directly at the machine, the print engine, and you have a long oblong in the middle here, and this can actually retract out toward you. This is the PR belt housing, which is a photoreceptor belt. This shiny blue object here is the PR belt. It's translucent, so light actually is shined through the belt, and it's designed to hold. It's what makes the science of the machine possible. Electromagnetic magic that only Bill Nye the Science Guy can explain to you. Because don't ask me how it works, but I'll tell you what I know and how I understand it. And as an operator, you don't always need to know every little component of the engineering of the machine, but it helps to have a concept of how things work, so that when something goes wrong, you know what responsibility is what, right? So what each component of a machine is responsible for. If something goes wrong, then you know, oh, it's probably this area, and you know exactly where to look. Otherwise, it's a clusterfuck, and you're just guessing and throwing, running tests, throwing new parts in, and right now it's a complete disaster. Shouldn't say that, but it's very inefficient, very wasteful, and Xerox is not very helpful either. So the people that make the machines are not very helpful. So, but I'm going to teach you how to do it the right way, and so let's get going. So we got the PR belt. What happens is this belt will rotate counterclockwise while the press is running. There's a bunch of sensors and stuff that are measuring different things, looking at different things. You have 4 stations, one for each color: C, M, Y, and K, cyan, yellow, magenta, and black. K stands for black because RGB is another print system where B is taken. B is blue. So CMYK, they use K for black. And there are 4 developer stations here on the left: magenta, yellow, cyan, black. And prior to each developer station is a charge station, AC/DC units, back in black. There's a charge station, AC charge, that precedes the developer housing. So what it's doing is it's laying a charge on the belt, and that is what attracts toner. The developer housing dispenses the developer material onto the belt, and then it moves on to the next color station, and then it transfers to the paper as long as you're running the machine. It does do its own color density calibration checks on the belt as well, so not everything goes onto the paper. It runs its own little calibration checks and registration checks. But I'm just talking about what happens. The process for printing is it puts it on the belt for each station, rolls, and then sucks onto the paper with the transfer charge. So the AC units are called dichrotrons. They have a 3-wire. All these metal housing shield things are called dichrotron units, and you have this plastic. You have 2 DC charge that are plastic, and they are pin scoretrons. They all plug into the back power supply, and the operator is responsible for replacing, cleaning both the wires and the grids. And the developer housing is, like I said, changing developer is rarely done now on the Igen4, and that's a technician only maintenance procedure. There is a wire module called the wire mod for short that is sitting on top of each developer housing. That is a component that is operator responsibility. There's no cleaning involved, but they get replaced on a regular scheduled interval. Xerox sets the counts for each component, and this one's 500,000 impressions, which is about the average lifespan of the component. It can last longer, sure. They can last 2, 3, 4, 5 times the life, but it's just a number so that operators are aware in the industry. If you're going to do maintenance, you can replace you can replace more than one thing at a time. A really good operator knows when something needs to be replaced, and then replaces just that thing. But it's not, I don't know if anyone besides myself exists out there that can do that, but it's not really, even for me, it's not really that practical, because you're sharing the machine with other people, and if you're going to do maintenance, it makes sense to have everything correct for the next shift so that there are minimizing problems. Especially in my position where I understand a lot of things, but not everybody else, not the other operators don't necessarily know. But through my training course, you're going to have the best of 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 the best information for operating this machine. There is no better. There is no better. Not that I'm aware of. I highly doubt there's better. Okay, so AC charge dicorotrons, DC charge pin scorotrons. These are the terminology from Xerox. They invented this stuff, so they called it what they called it. You got the wire modules I showed you. Each color, C, M, Y, K, black's at the bottom. There's a little hack roller down here. That gets dirty. An operator should be cleaning that during a photoreceptor belt change. A lot of maintenance. It's kind of a big deal to replace the photoreceptor belt. Xerox sets the count roughly. I've seen the count change, but I've roughly 1.2 million impressions on the photoreceptor belt. That is the only component that I have consistently been short of that interval. 6, 7, 800,000 is usually where I fall before a photoreceptor belt change is needed. But it all depends on what you're running. You know, you can let it go. It can run millions and millions and millions of counts if your image quality is not, if you run the same thing a lot, that's easier on the photoreceptor belt. If you have less coverage, if you have, you're not changing sheet sizes or anything. If you run the same thing, you're going to get a lot more life. If your image quality doesn't matter that much, or because you can't see the difference on what you're printing, then you just let it keep going, But I've always had to run a broad range of print jobs, so pushing the max of the PR belt is 600, 700, 800,000, pretty much, in my experience. But a lot of maintenance will be needed during the PR belt change. It's a great time, because this is a time when, it takes time to get things back the way they are, and you want to take your time and make sure you have everything cleaned before you put it all back in. That'll go a long way toward all the health of everything, toward your efficiency. Again, all the maintenance procedures I'm going to talk about later, but PR belt change. Cleaning this hack roller is part of it. Other than that, hack is hybrid air knife. It's shooting air out. There's one in the fuser as well. It helps separate the sheet from the fuser roll, so they don't stay. It doesn't stick or wrap around. So the paper is coming through the print path. The belt is rotating counterclockwise with images on it, and the image transfers between area 2 and 3. And then what happens, the sheet exits into 3, the belt keeps rotating. So what happens is you've now transferred image onto the sheet. There's still some developer material, there's still some material on the belt that didn't transfer because it's not super perfect, and there's other things, there's always going to be some residual, and so that has to get cleaned. So to the right, I forgot to mention there's a pre-transfer wire and grid dichorotron here before the transfer. And then over here is a pre-clean wire. There's no grid, but there's a pre-clean wire which just helps break up the toner a little bit before it hits the cleaner housing, which is directly above it. The cleaner housing is made up of 2 brushes. There's a cleaning blade, which damn near touches the photoreceptor belt when everything's closed back up. And the brushes are rotating and they're vacuum suction. And that all gets purged down to the waste toner bottle. And has a little catch tray. There's also an auxiliary magnet down here that catches a little bit extra that's just floating in space. The carrier, the developer material has carrier in it, which is steel bits. These little metallic bits can scratch the PR belt. So keeping things clean and keeping things off, keeping things relatively clean. The machine is not perfectly clean. There's always material free flowing in the air, and the auxiliary magnet catches some of the stuff that falls that didn't quite hit the cleaner housing exactly or whatever. But it's all just helping to keep things as clean as possible, and it's not perfect, but it's still pretty good. If your cleaner housing is not functioning properly, then you have a problem, because what will happen is you have residual developer material still on that belt when it rotates around a second time. And then the same process will happen. It's going to put more material on, and then it's going to transfer to the sheet. And then, you're going to have a little extra in your image. You go, what the heck is that stuff? And then it'll keep doing it. If you have a problem with your cleaner housing, then it's going to keep doing it. It's actually going to build more and more with each sheet that goes through. So these are all things that you are aware of as an operator, and being on top of your maintenance and being aware of what the health of the press will help you will help you prevent all these problems that could possibly happen. But I'm going to explain all the problems that could happen in the maintenance section. Later. I believe I mentioned the stab blade too in the last video, but the stab blade is strong transfer assist blade. While the transfer is helping, the sheet goes by, and it kind of has a little play, a little bit of lift. And because different sheets have different thicknesses and stuff, and when they come in, the transfer is not some sheets wobble more than other sheets. They're more susceptible, and the transfer voltages will vary based on the type of sheet too. But the stab blade helps with that. And the C-puck is directly underneath the cleaner housing. This is new to the Igen4. C-puck is cross-process uniformity controller. Ooh, big words. So I have to teach you all the terminology of the Igen so you can learn, the lingo for how to explain certain things. There's more terminology than you need to know, but the direction of the paper path, the direction the paper is flowing throughout the paper path is called the process direction. Cross process is the opposite. So the way also the way the image lays onto the sheet naturally, or actually I shouldn't say that. So if you're standing on the press, left to right is process direction. Cross process is, front to back. It's looking to the depth of the sheet or the width of the sheet. So you have cross process uniformity. Uniformity is keeping the image, the color density uniform from the front of the sheet to the from the outboard of the sheet to the inboard of the sheet. That's another way of explaining it. Outboard is me, inboard is in the press. So keeping that image uniform throughout the sheet. This little light lamp here is reading the color density test patterns on the sheet, and it's saying, do I need to make an adjustment, whatever, to get it to look the same? Because as the components are wearing, the density will change slightly. The voltages are not exact, and the density changes a little bit, and then it tries to say, okay, give it some more voltage in cyan, give it some more, give it some more, give it less, whatever. It tries to correct for that, and it's pretty good at it. If you have other problems, it might create problems. If you have any damage to the PR belt, you're gonna have problems. So dings or dents or scratches or marks. If I write on the PR belt, I say, fuck Xerox, sucks, or whatever, I don't know what I would write. Whatever I wanted to write. If I wrote onto the PR belt with a marker, it would actually come out onto the page. It wouldn't be on every single sheet because the length of the belt holds multiple sheets, but it would show up. And it would, but I would actually be mirrored. It would be a mirror image, so I'd have to write the mirror image. Hopefully I got that. Maybe the R is reversed, yeah. So fuck you, Xerox. No. Sorry. It's just an example. I'm just saying as an example. Okay, so yeah, if there's any damage to the belt, it's going to show up on your images. It won't, like I said, it won't be on every sheet, but depending on the length of the sheet itself, it might be every so often. It'll be the same number, 3, 4, 6, whatever. It's once it's damaged, there's only so many things you can do, if anything. So there are little tricks. Sometimes it's not going to show up if there's nothing there. If there's no print image there, you have white space on your page where the damage is, then you go, oh, it's not too bad. But essentially, you'll need a PR belt change, and you have to be very careful with changing that. I'll show you that whole thing, but it does damage easily. Handling is important. Handling of every component of this machine is very important. Even the doors, even the baffles, drawers, anything it's not super strong, super sturdy. You know, it's breakable, and you just end up creating more problems for yourself by not having good control. Okay, so that's the PR belt. I think that's everything. I always forget something. I always forget. There's other things in here, sensors and stuff. Underneath, when you remove the PR belt, there's a lot of stuff that has to be clean, rollers and stuff. That's part of the maintenance. Keeping things clean makes your life a lot easier. You're going to prevent problems. The stab blade gets cleaned periodically. Things can build up on it, and you have to be careful with that because it damages pretty easily. And the stab blade can cause problems with transfer. It can also affect your image quality, especially if it's bent and touches the PR belt. You can even scratch. It can scratch the belt or scratch the image right there as it's trying to transfer, or it'll poke through the sheet. Yeah, it'll mess things up. So or it'll jam, I didn't mention, but I think I mentioned, but every area in the press has its own sensor, paper path sensor. Area 1, area 2, entrance, exit, and the machine is checking the timing of the sheet as it travels through the paper path. It has to hit a certain window or else it jams. And it does that because there's pages behind it. If there's a reason why it doesn't make the timing, then something is wrong, right? Either the sheet got stuck somewhere, or it's bent, or it's, whatever. If it doesn't hit the timing where it should hit, then it stops the press and instantly. And the sheets behind it otherwise would just keep piling up, and you'd have a real big problem. You don't want those kind of problems. So the sensors will check the timing, and then it'll say, okay, within the window, keep going, and then, oh, somebody's late, stop. And it's very rare that somebody's late, but it happens. If something's on the paper, something's sticky, it gets stuck somewhere. There's occasionally, in area 3, it can hop over the sensor. It has like a cool, the paper has a weird curl to it or something. It might bounce a little bit. And if it hops over the sensor, then it stops. But it's sort of like the sensor never got a chance to see it. So the sensor is just shining a light up to a reflector, and then it looks for the reflection. It looks to see that light. And if there's paper there, it's not light. It can't see too good. It's covered up. So if your sensors get dirty, which can happen from time to time, then it might think there's paper there, and then it'll stay jammed, what is known as a phantom jam. So it thinks there's something there, but there isn't, and that's the sensor is dirty. And it happens in area 4, which I'm about to show you sometimes, because there's a lot of grease, there's a lot of oil in that area, and it's more likely to happen there. Even the heat can interfere with the mirror, the reflector. Yeah, usually either the sensor or the reflector is dirty. Okay, so we're going to close this back up. you're going to go in the opposite direction, the first black handle, and it takes a little pressure to get it to click in there. You'll hear it click. Second one, pressure. And then that latch at the bottom, don't forget you have to stoop down and pull it to the right to get it to lock. That does have a sensor. It does know if that's not closed. So if, you might walk away. It happens where you're focused on the PR belt change and doing the maintenance procedures, and then you go to close everything back up, and then it won't start, and you go, what's going on? And it says, I go, I forgot about that thing. And you close it. So it's just a thing that keeps everything safely locked. Yeah, so now that's locked. We're going to close up the doors, and this bottom right door right underneath the handles on the top, the door above. This is the fuser door, or area 4, and on the bottom underneath the fuser drawer is area 6. So first thing you'll notice is a giant metal fuser drawer, and you're going to release the latch here and just pull it all the way out until it stops. The end of the slides. It'll stop. You don't want to pull it forcefully. You just want to let it hit the stopping point. If you get pulling things too hard, they will break, and then you'll have a lot of downtime. It'll take quite some time to get these problems fixed. So handling is very important in everything. And I'll say that many, many times, because most of the problems that occur are from bad handling or just neglect, operator neglect. Okay. So we got this drawer. Now we have this little green hinge lever here, latch here, that pulls to the left and then out to the right. And now your fuser is in service position. So you can begin working on your maintenance procedures, whatever you're doing. And okay, so the big brownish roller here, rubbery roller here, is made of, is your main roller. It's called the fuser roll. And that is coated with silicone oil, which is called fuser oil or fuser agent or fuser fluid, depending on what you like to say. They're all interchangeable terms. And that is what keeps the paper from catching on fire. I think it helps somehow with the toner. The developer material, whatever. I don't know. You have to ask Bill Nye the Science Guy if you want to know the reason why it was chosen or why they designed it this way. I don't know. But Xerox is dry ink. Xerox comes from the Greek for dry, because they use dry ink. So the magic of dry ink is A, the xerographic components, and B, the fusing. So the magic of xerography happens, the magic of this dry ink stuff happens here. So the fuser roll, again, everything in the fuser right now is cold, so I can show you and touch things and show you. But typically when you're operating a machine, it's always hot. So it makes a big difference if you're working on the fuser, doing maintenance in the fuser when it's cold versus when it's hot. It takes a while to cool off. It takes a while for it to cool down. When the press is off, it just takes time, and it's faster to warm up. It takes 10 to 15 minutes to warm up from cold. So you have your fuser roll, silicone oil. It rotates, and it cams into the pressure roller, which is on the bottom here. This is hard steel roller, and the fuser roll is heated. The pressure roll is not. Paper comes through the paper path from 3 into 4, and then the fuser roll presses down into the paper against the pressure roll and melts the toner to the sheet. Heat, pressure, and then sheet exits, and the fuser roll backs off back to home position. And then same thing with the PR belt. You need to be able to clean. There's still some residual. In this case, the fuser roll is clean, but the paper has dry ink on it, so stuff melts onto the page, but a little bit will be stuck on the fuser roll still. So that needs to get off there so it doesn't go on to the next sheet. So it has its own cleaning mechanism. And you have two gray steel rollers, I believe, that are called external heat rolls, and they transfer the toner residual on from I think it goes the fuser roll to X roll 1 to X roll 2, and then X roll 2 is cleaned with this web cassette thing called the fuser web. And it is motor powered, and it continually adds fresh web material as the press is running and keeps wiping the X rolls clean. Again, this is another process that works well sometimes and not always. It really depends on what you're printing. If you print a lot of high coverage stuff with lots of toner involved, it's going to be harder for the press to maintain that for a long period of time. It's going to be slower to keep up with its own cleaning procedures. So this is things you would be good at as an operator. You have to get good at as an operator. You'll have to manually clean more frequently. You can manually clean the X rolls if you had to, and sometimes you have problems with your fuser web, and then it's not cleaning anything, and then it's building up more and more. That it gets to be difficult. The more you neglect the cleaning, the harder it is to clean in a lot of these rollers. Even the pressure roll gets dirty. You have toner. See, in the fuser, you have toner, you have oil, and you have paper dust. So the paper itself is producing its own dust. Some paper is worse than others. It depends. You might have your own cutting facility, and the knife used to cut it is kind of dull and worn out, and it leaves more paper dust. And and you just track it through the machine. You know, it builds up. So doing cleaning procedures makes your life easier, especially long term. Being aware of all these things is what makes you good at doing this job. Okay, so the yellow roller up here is the donor roll. That is transferring the fuser oil from the ram assembly. This is receiving fresh oil from the reservoir here at the bottom of the fuser drawer. This pulls out and you just add fresh oil, and you'll add that on occasion, not super frequently, but you're continuously adding new fresh oil as it gets lower, and it's pumping that oil into the ram assembly, which is going to transfer from a metering roller to the donor roll. And the donor roll transfers nicely to the fuser roll. So you have a nice even coating on the fuser roll. You don't want too much oil. You don't want too little oil. You want it to be just right. The ram assembly and the fuser. Let's say the fuser roll is operator maintenance. So you will assemble and replace the fuser roll. You don't really have to clean it. The press has its own cleaning mechanism. There is a way to clean it. You can clean it if you had to. But the press actually runs empty blank cleanup sheets in between each job to carry off any excess that wasn't cleaned off by the X rollers and fuser web. Any excess gets wiped onto blank sheets of paper. It'll run 5 sheets of paper, or depending on what you select as your cleanup stock, it'll run that paper, and it will anytime there's a jam, it'll do that. That's because it knows that when paper jams in the fuser, the toner tends to stick right on there, and it knows it's been sitting there longer, and the longer toner sits on the fuser roll, the more sort of baked in it gets. So it gets harder to remove. So it knows that its own process for self-cleaning is not going to be great. So it wants blank sheets of paper to wipe it onto before you wipe it onto your print job. So that's just to prevent image quality problems. But you can clean it yourself with fuser fluid. But we'll talk about that later. Replacing the fuser roll is about $500K. That you can't get a lot of extra life on fuser rolls unless you're running the same thing all the time. And it's not super image quality conscious. If you're just running, uncoated text or whatever, you can run all day. You can run that for a very long time. But if you need gloss, cover stock to look pretty, you're gonna need all your print components to be good, and the fuser does wear down. Same thing with the PR belt with the fuser roll is depending on the width of your sheet, you can have wear marks built in. So if you run 200,000 sheets of papers, we'll say, into the fuser roll that's 12 inches, you're going to have a wear mark, the edge of the sheet at 12 inches all the way to the end of the fuser roll, which is like 14 and a half or so. 12 to 14 and a half is going to look brand new, and up to 12 is going to look worn down. So it's uneven. So now if you have to run something that's 14 inches, it's going to show, the difference is going to show up in the image, probably, depending on what you're running. And the same thing will happen with the PR belt. It's going to lay the charge down unevenly. The edge of the sheet is going to stop, and you're going to have image quality problems there too. There are ways to work around it to get it to last longer and stuff, but I'll get into that later. The fuser does have its own RDS thing, right? Forget what that stands for. Distribution something, rotational distributions system or something, where it just it moves a little bit left and right, so you don't have a exact sheet edge burning into the fuser roll. It gives it a little extra half inch on each side play, I think, something like that. But in any case, you'll replace the fuser roll. You won't touch any of the other rollers. You can clean the pressure roll, which I recommend, even though Xerox doesn't actually say to do that. I think that's a daily thing. I always clean it daily because it builds up and then it gets really hard to clean. If you wipe it daily, you have a better health of the pressure roll. And there's a stripper finger bars here that do their own cleaning too, but it doesn't do that much. I mean, it gets a little bit, you clean those off, but you still want to manually clean the pressure roll. The donor roll, X rolls, that's all technician only maintenance. You can replace a fuser web, that's operator maintenance, but rebuilding a fuser web with web material is considered Xerox technician maintenance. I do that myself because it's fairly easy, and it's just if I know how to do something, I'd rather do it myself, because I know what was done. If there's a problem, then I'm the one that did it. So the RAM assembly, this is another maintenance procedure. The oil has to get changed out every so often, because the RAM assembly, the oil will gets contaminated with paper dust and build up gunk and stuff. The oil starts to get cloudy, clay colored, and that will affect your image quality on anything that's coated, gloss coated stocks. They call it gloss differential. You'll see that the gloss pattern is like ugly, uneven, or ugly, and it ruins the quality. And that comes from bad oil. The oil is too old, it needs to be changed out. So you're adding fresh oil in the reservoir, and the reservoir stays clean for a very long time. I would replace or I would clean out the reservoir maybe every year or so, or even a little bit longer than that. It doesn't need it that frequently. It does get contaminated eventually, but it's covered with a cap, so it takes a while to get contaminated. But all the fresh oil you're adding gets pumped in, and then the ram assembly, which holds it temporarily, does get contaminated fairly frequently. 500,000 clicks or so, impressions or so. It will, you can do maintenance maybe a little bit longer than that. It depends what you're running. Again, everything depends what you're running. You can let something go a really long time if the image quality doesn't really matter that much, or it doesn't show up. Otherwise, it's about 500,000 you want to do RAM assembly maintenance, and that is a technician only maintenance as well. I do that myself because I prefer that one especially. I prefer building fuser webs is not that fun, but the RAM assembly needs to get done when you need it, and you can't wait. You can't have, it's silly to have downtime over something like that. So I prefer to do it myself, but Xerox has it as technician maintenance. Yeah. That is the fuser roll, or that is the fuser area. Just making sure. Yeah, all the maintenance procedures for changing out the fuser rolls and stuff. I have to show you. That's all stuff you'll get comfortable doing in time. It's a regular part of everything. Fuser and the xerographic area are very very important areas of this press for image quality, and so knowing what you're doing makes the difference. Makes a big difference. And yeah, just trying to make sure I got everything. Yeah, all the responsibilities for the operators, responsibilities for the technicians. I'll go over all that stuff again in the maintenance stuff. Closing this door, to close the drawer, it seems easy, but again, it's another thing that you can't close it too hard. If it'll let you slam it, if you slam it, it'll slam, and actually it has its own mechanism that if you do slam it, that it triggers a switch which disables it. So if you slam it too hard, and then you go to run something, it won't work, and you'll go, what the heck is wrong? It's closed. What happened? And yeah, I mean, it has its own mechanism if you slammed it too hard, so you have to manually flip the switch back if you want to get it to run again. Again, that's information that a lot of information wasn't really passed down. A lot of the things I learned was complete trial and error, and frustration and all that stuff. So I'm just going to teach you the right way of doing things. So everything's delicate. You get the feel for everything that you do. You want to hear, listen for the click of the latch. You want to, hear the door. Get used to the pressure the amount of pressure, the amount of force you're using. All these baffles in the print path. Close them tight. Make sure they're latched completely. The dichrotrons and stuff, same thing. You don't want to slam them in there. You just want them to be all the way flush. If you slam them, you can actually, similarly, you can knock the power supply in the back off and disconnect it, and then it does nothing. And then you'll have a problem. You can't figure out what's going on. So there's a lot of things where handling is can get you into trouble. Mishandling can get you into trouble. Okay. So that is the fuser. I believe that's everything. Just want to scan over real quick. I would say one thing, keeping the surfaces of the fuser clean is important. It's not stressed very much in Xerox training, or stressed at all really, but keeping the surfaces of the fuser clean, the metal surfaces, there's a lot of grease and, like I said, there's oil, there's also grease that's used to lubricate the gears in there, mechanical gears, that when you're touching things, you can transfer it. That'll transfer, and sometimes it'll get on the surfaces and stuff, and keeping things, if you neglect this, eventually it builds up and you can have problems, image quality problems. So keeping everything clean makes your life easier. At the sheet fuses, exits, and we already covered the rest of the paper path through the finishing units. And that is it. We made it. So that's the print engine, xerographic area, xerographic components, and the fuser components. Next time we talk about setting up print jobs, setting up the drawer for the feeders, assigning paper stock, and that's all software, that's all operating a computer. And you got to familiarize yourself with that as well, and then we'll just start releasing jobs, and I'll show you how it prints, and we'll take a look at some sample sheets, and if there's that, we'll show you the process. Once we move on to maintenance, we're going to be anything that comes out that has a defect, I will point it out. And in the meantime, as we are learning each maintenance procedure, and this takes time, this takes practice. This is the months and months and months, right? This is the months of getting the feel for everything, remembering how to do these things, and then paying attention to the print output, and inspecting and looking for print quality defects or artifacts that show up, and making the appropriate correction, or starting a troubleshooting process if you're not exactly sure. Sometimes you don't know what's causing that, and you go, let's narrow it down. It's probably this. We'll try working on this area. Let's narrow it down. So you might have something wrong with cyan, right? Everything looks good except the cyan's coming out bad, and you want to know if it's the AC charged wires that's causing the problem. So as a quick trick, you might take the cyan dichorotron, AC charged dichorotron, out of the machine and swap it with another color. I'm going to put it where black is. I'm going to put it where magenta is, or whatever. And let's see what happens. I'm just going to just print and then just test to see, did it change? If you have the same problem exactly, then you know it wasn't that. This is an example of troubleshooting. You're trying to narrow down the source of the problem. Running simple tests. Okay, that's all for now. We'll get into the software, Xerox Free Flow, and the PSIP, which has the stock settings and trays and diagnostics procedures, and that everything takes time. It all takes time to learn. So that's that. See you next time.